Hello there. My name is Francisco Picado. I am a mathematician at Dixtior Consulting, and I work as a data scientist. I come here to present to you our model, outlier adjusted Gaussian mixture. Our presentation has around two parts, the one where I present the model and the one I present the more business-oriented part of our product. So our model is a clustering model. So that means that we want to group observations based on similarities between them. But let's start from the beginning. So we consider observations as vectors with d coordinates. Those coordinates correspond to the variables that are decided by the business experts. Well, d is usually a natural number, so don't worry about that. So anyway, an account is a vector with the variables where each coordinate corresponds to the value in that coordinate. So we want to group these vectors based on the distance between them. Usually, we consider distance to be the Euclidean distance, where the distance between each vector is the square root of this sum I'm drawing over here. And in case this actually scares you a bit, this is just the Pythagorean theorem, but generalized. So this is not too difficult. All right, so clustering in mathematical terms is what we call a partition. So if we have a set like ABC, we can partition it as a set containing A, a set containing B and C. Let me just draw that a little bit better. Okay, and what we want to do to our account is pretty much the same. So I said we have d variables, but we're three-dimensional beings, and so it's easier to visualize if I draw it as a two-dimensional example. So let's consider an axis where we have around two variables, great, and each account is interpreted as a point in that space, as you can see over here. Usually real numbers, so again, nothing too fancy. And then what we want to do is that we want to group this in terms of distance. So we can just, a possible grouping is something like this. Grouping, grouping, grouping. And this would be a possible cluster. Our model is based on the Gaussian mixture model. There's also another clustering method that's called the k-means clustering. However, the k-means actually works better if the data is dispersed in a circular fashion, as in the Gaussian mixture. The Gaussian mixture is way more flexible because it allows for data to be dispersed in a circular fashion, but also in an elliptical fashion, because after all, an ellipse is just a generalization of the circle. And so we believe that the Gaussian mixture actually fits our data more nicely, and that's why we use it. However, we actually changed a bit the Gaussian mixture model because of extreme examples. So let's consider this example where we have some accounts over here, some accounts over here, and some accounts over here. Now, the regular Gaussian mixture would just group this as ellipse, ellipse, let's just give it another color. No, okay, and let's give it another color. Great. So the problem with this is that this account over here is fairly different from this account over here because it's fairly distant, and we do not want this. So we need to control the dimension of the cluster in a way so it displays a more accurate behavior. And so our method starts by testing out for centers because ellipses and circles need centers. And so iteratively, we start and try to find centers to each possible cluster. We test each account and then we try to figure out which is the center of each set of observations. This can be done randomly or using the k-means just to get an idea as to where the centers are. Okay, and then we have our centers. Again, with the centers, we also get a correlation matrix that gives out a possible behavior of our model. But then, um, we need to actually decide, for instance, if this point over here is really going to this cluster, or if this point is really going to this cluster over here. And so the assignment to each cluster is done by soft assignment. So we calculate the probability of each account belonging to a single cluster, and that can be calculated using some really heavy expressions. But visually, the idea is that as soon as you have a center point and parameters, you can draw in 2 dimensions. It's called a rectangle. In many dimensions is called parallelepipeds, or just an n-dimensional. Well, it's the Cartesian product of intervals. And so with help of business experts, we get parameters in order to draw the limits on the variation of these accounts. And then based on these limits, we can then cluster them based on the parameters that are acceptable. And so we get this cluster over here, this cluster over here, and this cluster over here. And these other clusters that we've left outside the limits, all right, let's not choose the same color. Let's just give out this a reddish color. No, not reddish color. A dark orange color, in order to signal that these are considered outliers. And so for each outlier, we give them a cluster of their own, and they are treated as the center of their own cluster. And they have also a correlation matrix. So the general details of this calculation are explained in a report that our company issued, and you can read through that if you're curious. This is the visualization. So if you have points, you then try to find centers, and then try to limit the variation that you want to see, and then cluster them based on said limits. And the rest are set in outliers. So this is the mathematics of our model. So what we now want to do is to attribute risk to accounts. So this is the more business-oriented part of our model. We need to convert we need to group the transactions made by a single account. And usually we consider, so again, we have the same vector, we have some coordinates, and what we consider is monthly averages. We could have done it any other way. However, we've chose to do it in monthly averages. And so the dots that go into our model are actually monthly averages of that account in those variables. So now for the second part of our presentation is the more business-oriented part of our presentation. So let's consider now that we have some accounts over here, some accounts over here, and some accounts over here. And we've now got the clusters, and we have the center points of each cluster. Now it's the part where we talk about risk attribution. Now, risk attribution is actually pretty simple. So the risk that we give to an account is the risk of the cluster that it lies in. And so that risk is usually a number belonging between 0 and 1, a real number. And what we do is that we convert it to a discrete scale of 1, 2, 3, 4, etc., because it's easier to interpret if that risk is high or lower in terms of levels of risk. And that is done, well, now we have a function that picks a cluster and it attributes it a risk between 0 and 1, and then it goes through another function that takes that output and converts it into a number of in this set over here, so that we know if it's high or low. So now that we have the clusters, now that we have the risk attribution explained really shortly, because this expression has a really weird details that I don't have the time to explain, but that can be consulted on our report. And now the most important part is, so now we have the clustering, now we have the centers, we have an outlier over here. It's important to know that the centers do not change, the ellipses do not change, the parameters of our model do not change at all. The evaluation of this process, that means that we assess the behavior of the certain account daily, but the clusters, the center points that we've generated, do not change. That means that, for instance, if we have this account over here, for instance, it can belong to this cluster, but it can also, just because life changes, and it can just change cluster and be an outlier, or just go to a different cluster. And that is done daily. But what we've done here, the ellipses that we've created, the center points, etc., does not change. And that's how we confer risk to an account. So anyway, that's been our presentation of the outlier adjusted Gaussian mixture. I'm Francisco Picado. Thank you for hearing me. If you have any questions, you can ask them in the Q&A. Thank you very much.